next lesson you guys are going to be learning about is conditional probability. This is another review concept when it comes to probability. And so I'm going to be going through the information fairly quickly. So if you do need additional examples, please make sure that you go to YouTube, Khan Academy, whatever you need to get the additional help that you need with conditional probability. But your goal for today is that you guys are going to be able to find conditional probabilities under different given conditions. So let's take this example right here. This example says, in a class of 25 students, 16 students study French, 11 students study Malay, and 4 students study neither language. Now, you're going to represent this information in a Venn diagram, and then I want you guys to answer these next 4 questions. So pause the video and answer these next 4 questions. So hopefully you used your combined events formula to see that the Venn diagram, there were 6 that studied both languages, and that there were 5 that did only French. 10 that did only French, 5 that did only Malay, and then the 4 that did neither. Remember, anything that's not a part of the 2 sets always goes inside of the universal set, and please make sure that you always include that rectangle as well as a U to represent the universal set. Over here is the work that goes along with the addition rule. So the probability that the student studies French and Malay, remember and is the intersection, so the probability of that would be 6/25, studies exactly one language, so that means studying only French or only Malay. Well, as you can see, that's a total of 15 out of the 25 students who are in the class, and of course that can be reduced down to 3/5. Always make sure you reduce your fractions. The student does not study 2 languages. Well, if a student does not study 2 languages, that means they study exactly one language, or they study no languages. So that is the 10, that's the 5, and that's the 4, because you can't forget about those 4 students that don't study any of the languages at all. So that's going to be a total of 19 out of 25. And then the student does not study French. Well, that's everything outside of the French bubble, which are the 5 that study Malay only and the 4 that study neither, for a total of 9 out of 25. Now, this is just to review from last week, because a lot of these questions are going to incorporate pretty much all of the probability unit. So they might have you do some basic things from before they actually incorporate maybe something a little bit harder, which you guys are going to see. And if you were wondering, this is what the extra credit was last week. So, what is the probability the student chosen at random studies French, given that the student studies Malay? Now, this particular wording is an example of conditional probability, and that's what you see the notation at the very bottom. Probability F line M. This line right here indicates conditional probability. Okay, and the part that follows this line, the M, that represents the condition. That means that we're no longer looking at the entire universal set. Now we're only looking specifically at the students that study Malay. And so out of those students who study Malay, what is the probability that the student studies French? Okay, so then we're basically determining the probability that F occurred when you're only looking at the Malay students. So remember from the other Venn diagram, this right here was the Malay students. So, and this was 5 and this was 6. So now we're only looking at just the 11 here, not the whole 25. So Malay is 11. Out of those 11 students, how many studied French? The overlap here, these 6 students study French and Malay as well. So when it asks you what's the probability that a student studies French, given that they study Malay, would be 6 out of 11. 6 to represent the French and Malay students, and then the 11 to represent just the Malay students in total. There is a formula for conditional probability, and this is what you see here. Again, the line indicates the condition, and the part that the line indicates conditional probability, and the part that follows the line is the condition. So the formula is the probability of the intersection of A and B, or whatever the 2 events are, divided by the probability of B. If you notice, whatever the condition is, that is going to be your denominator. So what you see in the handwriting of the blue, if it were switched, the numerator is still the intersection between A and B, It doesn't change whether it's A and B or B and A, they're still the same, but the denominator does change because now the condition is A and not B as it was before. So be very cautious about which part is the denominator. And you'll always know which part is the denominator if it follows the words given that, or such that, or even the word if, because now you're no longer looking at the entire group, you're only looking at a certain part of the entire group. So if I go back to this particular problem here, you see how it says given that the student studies Malay? That lets us know that the condition is Malay, and out of those kids, that was going to be our denominator. Okay? So let's take a look at this example here. Still talking about French, still talking about Malay. All right? It says in a class of 29 students, 20 study French, 15 students study Malay, and 8 students study both languages. A student is chosen at random from the class, and we're going to find all these different probabilities. Now, before we get started, yes, a Venn diagram can be very helpful here because then we can kind of use that as a reference. So I want you guys to do now is I want you to pause the video, and I want you to draw the Venn diagram to represent this particular situation, and then when you're ready to see the answer, as well as go over parts A through G, press play. Hopefully you got this as your Venn diagram. Why do you put French on the left, Malay on the right? Since I did have 8 students that study both languages, that lets me know my intersection was 8. And that also let me know that the ones who studied French only was 12 and not 20. Remember, if it says that 20 study French, that means that entire French circle should be 20, not just the part that's French only, the entire thing. And they'll use keywords like only or just to let you know that they're exactly to put the number. So then that means 7 students study only Malay because 15 study Malay together. So that's the 8 that did both and the 7 that did only Malay. And if you notice, 12 plus 8 plus 7, that's 27 and not 29. So then that lets you know that 2 students were left out that don't study either of those languages. So let's find the probability that a student studies French. That's in general. We're looking at the entire universal set. So that means that's going to be 20 out of 29 because there's 20 students that study French and 29 students in total. Not 12 out of 29 because it didn't say like the word only or just. You see what I'm saying? There's a difference. What about studies neither languages? Again, we got the Venn diagram right there, and we can see that the ones that study neither languages, that's 2 out of 29. Studies at least one language. Tricky wording, at least. That means that they can study one language or more. So in this case, it's either 1 languages or 2 languages. So that's going to be a total of 27 over 29 because there's the 12 that study just French, the 7 that study just Malay, and then the 8 that study both. That is at least 1 language. Studies both languages, as we can see, that's going to be 8 over 29. Having the Venn diagram is very helpful. Now here comes the conditional probability questions. Studies Malay given that they study French. Now I'm looking only at the French students because remember the part that follows the words given that indicates our condition, indicates our denominator. What that would look like? That would look like probability of M line F. Okay, remember that line indicates conditional probability, and the condition always follows the line. So that's our order. So our denominator represents the amount of students that study French. Well, that is 20 students that study French. So 20 is going to be my denominator. And then my numerator is going to be, out of those 20 kids, how many study Malay? And that's going to be 8. So my answer is 8 out of 20, which does reduce down to 2 over 5. Okay. Now, if you notice, I'm not fully using the formula because the formula says the probability of the intersection divided by the probability of the condition. So if I wanted to do this properly, then I want to do the probability of the intersection of M and F. And then I want to divide it by the probability of F, okay? And I'm just showing you this real quick so you guys can kind of see essentially with the formula what it would look like. The probability of the intersection of M and F, well, that's going to be 8 over 29. That's actually what our numerator is, okay, because that represents the intersection. The probability of F, the probability that a student studies French, well, that's 20 over 29. So before we even simplify any of this, and I'm just going to do this real quick so you guys can see it. This is what we have. Okay, this is using the actual formula. Now, when you have a fraction within a fraction, you guys know you keep change flip, you keep the numerator, change the division to multiplication, flip the denominator, and then that's how you end up getting 8 over 20, which is 2 over 5. This is the shorter way to do it, especially if you have the Venn diagram already there, but this is the proper way using the actual probabilities. This is also how you would show in a conditional probability. Okay, so be careful. F, probability that student studies French given that they study Malay. How that sets up, that's going to be French given Malay. Okay, so it's backwards this time. Now, our denominator is no longer 20. Our denominator is going to be 15 because we have 15 Malay students. And out of those 15, there are 8 of them that study French, and that does not reduce. Now it says studies both languages given that they study at least one language. Now, if you notice, we've actually know how many study at least one language. We found that back out in part C. So the students that study at least one language, that's going to be 27. So our denominator is going to be 27. So let me go ahead and set this up. It's going to be probability of both languages, line at least one language. All right, so that'll be the setup. So our denominator is going to be 27 because there's 27 students that study at least one language. And out of those 27 students, there are 8 of them that study both languages. And that does not reduce. And that's how you do conditional probability, okay? You want to make sure that whatever follows the words given that, another set of words are such that, or even if there's like a sentence that basically says, now we're only going to look at the French students. Out of the French students, and so on and so forth, that is also an example of conditional probability. But no matter what, the condition is the denominator. You can even do it from a two-way table. That's exactly what this is. It's a two-way table. I want you guys to give this one a try. Pause the video and press play when you're ready to see the answer for this problem. Leanne goes fishing at her favorite pond. The pond contains 4 different types of fish: bream, flathead, whiting, and salmon. The fish are either undersized or normal. This information is shown in the table below, and so you're asked to write down the total number of fish in the pond. Very simply, you can either add up the totals of the sizes of the fish, or you can add up the totals of the types of fish. Either way, the answer is still going to be the same. The answer is going to be 90. Okay, and it always will be in a two-way table. So easy 1 point there. Now, Leanne catches a fish. We're going to find the probability that she catches an undersized bream. Undersized bream. So how we do this, we go to the table, we locate, okay, here is undersized, here is bream. That point is 3. There were 3 undersized bream fish. So that's going to be 3 out of 90, which does reduce down to be 1 over 30. So our final answer is 1 over 30. It says capture either a flathead or an undersized fish or both. Okay, so this is pretty much representing the union of flathead, undersized fish, or both. So think of it, the Venn diagram is the intersection of the 2 bubbles, that basically both bubbles. So we have We have 23 flathead fish. We have 42 undersized fish. And then there are 12 fish that are flathead and undersized. Now do realize that if you were to add 23 and 42 together, you've actually have counted these 12 twice. And so when you think about the combined events rule, when you take the probability of one plus the probability of the other, you have to subtract the fact that you are overlapping when you add both of those types twice, so or together. So You want to make sure that if you're going to add 23 and 42 together, you subtract your 12. So 23 plus 42 minus 12, that's going to be 53. So there are 53 fish out there that are flathead, undersized, or both, and that's going to be out of 90. Now 53 over 90 does not reduce, I don't believe. So we're just going to leave as 53 over 90. It's better to leave your answers as fractions, because if you don't, then now you're resorting to three significant figure rounding. And some of you guys are still having difficulty with your rounding, so it's better to be left as a fraction, unless the problem tells you to do so. Now it says, what's the probability that it does not catch an undersized whiting? Okay, well, an undersized whiting, there are 18 of those possible. There's 18 undersized whiting fish out there. Now what you can do is you can count up all these other fish, all these other types, all these other sizes, or you can do the complement. Since you know that there are 18 out of 90 fish that are undersized whiting, then what we can do is we can subtract that probability from 1 to find the actual probability of not catching an undersized whiting. So when we do that, we'll end up getting 72 out of 90. So there's 72 out of 90 fish that aren't undersized whiting, and that does reduce down to be 4 over 5. Now, if you're like, I don't understand how you did the 1 minus part, well, if I were to count up 3 plus 12 plus 9 plus 13 plus 24 plus 11 plus 0, that would give me 72. And that basically represents all the other fish that aren't undersized whiting. The easier way would be to do the complement, because the complement is based everything else that's not an undersized whiting. Now it says catches a whiting given that the fish was normal. Do you see the key word? Given that. Okay, that word right there indicates that we have a conditional probability. The condition is what? Hopefully recognize that the condition is that the fish is normal. Okay, so we're trying to find the probability of whiting given that the fish is normal. So that means our denominator is going to be the normal fish. How many normal fish do we have? That's 48. So our denominator is normal. And then out of these 48 fish, how many of them are whiting? As you can see, there's 24 normal whiting fish. That's the intersection between normal and whiting. Okay, over the probability of just normal, which is 48, and that reduces down to 1 over 2. How'd you guys do? Hopefully you did well. Okay, I want you guys to give this one a try, and then when you're ready to see the answer, press play. I'm only going to explain D part 4. Actually, no, I remember this problem. This problem was actually from a previous pod, and I don't have that part A, B, or C before. So you guys are actually not going to be able to do this one. So I'm going to go ahead and X this one out and let you guys know that this is the end of the video with conditional probability. The main thing I want you guys to be aware of is this part right here again. That's the formula. And remember, whatever follows the line is the condition, that is the denominator. Okay? Now, there is going to be an extra credit opportunity. I'm not going to skip past that. It is going to be on Schoology, and there are a few stipulations this time. There's going to be one problem. This problem does deal with conditional probability as well as some concepts from the previous lesson, and you're only going to be given 10 minutes to complete the problem. So once you start it, you are going to have a time limit. You only have 10 minutes to complete the problem. If you're wondering, is it an A, B, C, D, E, F, G? It is not. It is only an A, B, C problem. Okay? It does deal with conditional probability as well as concepts from the previous lesson. Testing to see if you understand the other rules as well as the rule for conditional probability. The deadline for this is going to be April 24th by 11:59. So I suggest that you do watch the video, do some practice problems from the homework, and then complete the extra credit opportunity, of course, by Friday. And we'll see how you do. If you have any questions, make sure you join us on our lives.